Hello everyone, this is Ketish here. In this video, I'm going to go through the AQA Chemistry Paper 1 Higher Tier from 2022. This is question number 5, which is on the topic of atomic structure and the periodic table. This question is about groups in the periodic table. The elements in group 1 become more reactive going down the group. Rubidium is below potassium in group 1. 5.1 Rubidium and potassium are added to water. Describe one or predict one observation you would see that shows that rubidium is more reactive than potassium. Now you should know that in group 1 it starts with lithium, potassium, calcium, rubidium is B, and francium Fr. As you go down the group, reactivity decreases. So one prediction. Now because the reactivity that's wrong, doesn't decrease, it increases. Sorry. So because the reactivity increases down the group, you will see that it's reacting more vigorously. How would you see that? It would fizz more, and potassium actually burns with a lilac flame. Now lithium just fizzes about. Calcium will be more reactive than potassium, so rubidium is going to be burning with a much brighter flame, you could say. So any of these 2 points should be enough. More vigorous bubbling for rubidium, or bigger, brighter flame for rubidium. 5.2 Explain why rubidium is more reactive than potassium. Now as you go down the group, the number of shells increases. Now remember that lithium is in the second period, so if I was to write the period numbers down, so helium and hydrogen is in the first period, so lithium is in the second period, which means it has 2 shells. Potassium is in third, so 3 shells. Calcium has 4 shells, rubidium has 5 shells, and francium 6, which means as you go down the group, the size of the atom increases. If the size increases, that means you could say that the atomic radius increases. Now the way that rubidium and potassium actually react is by losing an electron. So the easier they lose that electron, the more reactive they are. So rubidium, the electron is much further away from the nucleus, so there's less attraction to the nucleus. So here's an answer for the 3 marks in 3 bullet points. Rubidium's outer shell electron is further from the nucleus, so there is less electrostatic attraction between the nucleus and the outer electron in rubidium. So you could use the word electrostatic because nucleus is positively charged and the outer electron is negatively charged. So the outer electron in rubidium is more easily lost, hence it's more reactive. 5.3 Complete the equation for the reaction of rubidium with water. Now rubidium with water, you will get rubidium hydroxide, so RbOH, and hydrogen gas will be produced. Now you will need to balance the equation, hence you've got 3 marks. So you've got 1 Rb and 1 Rb. Rubidium is balanced, 2 hydrogen, that's 3 hydrogen on this side, so you've got 1 and 2 over here. So if I add a 2 there, that will make it 4 hydrogen, so add a 2 there. The hydrogen is balanced. Now the rubidium needs to be balanced, so add a 2 there. That should balance out the whole thing. So I could write state symbols. That's a solid, that's a liquid, that's an aqueous, and this is a gas. The noble gases are in group 0, which is a correct statement about the noble gases. Tick one box. The noble gases all have atoms with 8 electrons in the outer shell. That is, all have atoms, so that's nearly correct, right? But it's not, because helium doesn't have 8 electrons, it has only 2. So note that, because that's an easy mistake to make. Helium has only 2 in the first shell, which is full. The noble gases have boiling points that increases down going down the group. Yes, that is correct. Generally, I think if I write helium, neon, argon, krypton, and as you go down the group, the boiling point will increase because the atomic size increases, van der Waals forces or intermolecular forces increases. They are not diatoms, so they are not made out of two, they are not molecules, they are monoatomic. They react with metals. No, they don't. Table 1 shows information about the 3 isotopes of neon. So calculate the relative atomic mass of neon. Give your answer to 3 significant figures that would give a mark. So how would you find the relative atomic mass? You multiply. The way they have given it in the table makes it easy. You multiply the mass number by the percentage. So you multiply those two numbers, add that to the multiple of these two numbers, add that to the multiple of these two numbers, and then you divide the entire thing by 100. So let's do that. 20, I say AR equals relative atomic mass equals 20 times 90.48. Put that in brackets. Add that to 21 times 0.27. Add that to 22 times 9.25. And that in brackets. Put the entire thing. Right. Divide the entire thing by 100. That should give you 20.1877. Now, write that in 3 significant figures. You will have to round this up. So 20 point, oops, you can't see it. 20.2. That brings us to the end of question number 5, and I will see you in question number 6.